Okay, so let me get back over here to where we were. We had been working on, or we did a little introduction to weather the other day. If you would, really quickly, with your table group, just go through the top part of our sheet just to review so you can get your mindset on what we're discussing. Do that with your table group, please.
Okay, the first, the daily condition in the atmosphere. Energy it receives.
Okay, now you're tired. Okay, so there's really 4 things that we said that affect our weather. Can you name one of them, please? Raise your hand and tell me. One thing that affects weather. Give it to me. Rhea.
The water vapor.
Water vapor is one thing. Analia. Analia. Heat energy. Very good. Croy.
Air pressure.
Air pressure. Yes. And winds. Those are 4 things that we're really going to be focusing on as far as weather forecasting and predicting goes. I want to start out today looking at heat energy and how that really plays into how air moves on our planet. How air moves on our planet. So, does everybody see where we are in our notes? Yep. Okay. Before we write anything down, I just want to talk this through with you. How many of you guys have heard the word radiation before? Okay. Usually when we hear the word radiation, we think cancer treatment, right? Or something bad. You don't want to get exposed to too much radiation, right? But we do need a certain amount of radiation from the sun for our planet to get heat, right? And we use radiant energy all the time. For example, have you ever warmed your hands in front of a fire?
Yes.
Then you've experienced radiant energy. It's heat from a source, and you don't necessarily have to be touching it. It travels through the air or through the atmosphere. Well, that's what happens on our planet. We obviously have our heat source, the sun, and radiant energy from the sun strikes the planet. Now, when it hits the planet, it heats up the surface of the earth, doesn't it? We really, you can tell it in the summer a lot of times. Have you ever walked barefoot on a sidewalk or something in the summer? And what does it do to your feet? It burns them, that's right. And it's not that somebody, plugged in the sidewalk to something, an electric generator that produced heat. It got all that heat from the sun, right? Radiation from the sun. So, as the rays from the sun strike the surface of the earth heats up. But covering our planet, we have this blanket of air that we call the atmosphere, right? And so, as the surface of the earth is in contact with that air, the air heats up as well. Now, what happens when air heats up? Warm air does what? What does warm air do? It rises. And then as it moves away from the surface of the earth, it cools off. Then what does cool air do?
Come back down.
Yes. So warm air rises, cold air sinks. Warm air rises, cold air sinks. Warm air rises, cold air sinks. And all of a sudden we have this circular motion of air movement. Okay, air moving. What's the general term for air moving? Wind. Thank you. So wind is generated from that whole process of the sun heating the surface of the surface of the earth heating the air that surrounds the earth. Warm air rises, cold air sinks. And it's a cycle that happens over and over and over. This even happens over the ocean as well. All right, so on your notes, let's give some scientific word definition to what we've just talked about. Again, radiation we're going to define as heat from the sun, and it heats Earth's surface. So again, we have heat from the sun transferred to the surface of the earth. So far, so good, right? Second thing that happens, the surface of the earth is in contact with the air. And there's a transfer of heat from the surface of the earth to the air. It's called conduction. Everybody say conduction.
Conduction.
Thank you. So the surface of the earth is in contact with the air. Heat transfers from the surface of the earth to the air. It heats the air. Then that warm air begins to what?
Rise up.
Rise. And as it moves away from the surface, it cools off. Cool air sinks. That process of warm air rising, cold air sinking is called convection. Convection. Convection causes warm air to rise, cold air to sink. Warm air to rise, cold air to sink. And this happens over and over and over. So again, radiation is heat transfer from the sun to the surface of the earth. Conduction, transfer from the surface of the earth to the air. Convection, warm air rising, cold air sinking. And that process happens over and over. Croy?
Is it the same thing when you're looking at a road and there's like water? It looks like water right there, but it's not.
That's because there's a lot of reasons. It depends on the moisture in the air too, but you can literally begin to see that warm air, those air molecules being excited
Yeah.
and beginning to rise. You're right. Yes.
Is that what they call it, like a convection oven?
Because in the convection oven, there is this process of warm air rising, cold air sinking, so that the whole oven stays at relatively the same temperature. You know, most ovens it's not a convection oven, it'll have like a warmer spot and a colder spot. But if they can get this convection current to work, then it'll be the same heat throughout. Yeah, very good. All right, guys. Well, the other thing that I want to kind of define today for us is a word that we've already been using. It's the word humidity. So when we say humidity, what are we really talking about?
The moisture in the air.
Moisture in the air. Very good. We call it water vapor. So humidity is just another name for water vapor, right? But we've been measuring humidity, and we've been calling it a certain percentage, haven't we? 97% humidity. So that's really a measure of the moisture in the air, and it's called relative humidity. Relative humidity. So again, what's the relative humidity? It's just a measure of the amount of humidity in the air. So, once again, when I say the relative humidity is 70%, what does that mean? What does it actually mean? It means that the air is holding 70% of the water that it could possibly hold. What would be the maximum that it could hold? 100%. Okay? So that's just helping us to recognize how much water vapor is in the air. I'm going to ask you to go ahead and write that down for me. Yeah, this is my son. He never calls me during the day. Can you give me just a second to make sure he's not having an emergency? Hey, I'm in class. Can I wait? Okay, so you'll be all right. I'll call you as soon as school is out, okay? All right, tell them to go ahead and do it. All right, fine. It's a mother thing. When son calls from college, you got to make sure everything's okay. All right, so the other thing is we've mentioned, what does 100% relative humidity mean? You don't have to write this down, but what does it mean?
That is the whole area.
Probably about radiating.
Yeah, it's holding the maximum moisture that it possibly can, which means it's probably going to what? Rain. So I would go ahead and even say 100% probably means it's going to rain.
It's hard to say is water vapor can
Hold.
hold on.
I know that. That should say hold. And I don't know why the D. I've tried to fix that, and I don't know what the deal is.
Halo.
Yeah, it looks weird, doesn't it?
Hola.
Little Spanish. Wanted to throw that in there. Okay. All right. Now, you'll notice that there's a little bit of white space that we haven't written anything in. Do y'all see that? Okay. So kind of out to the side where it says, "What is how does air pressure affect weather?" Does everybody see that? There's a little extra space there. If you don't have extra space, then you may want to put a star on the front and put "see back" and use the back of your notes, because there's a couple things we want to write down. Remember, this is just a guide, right? Does this mean this is everything? No. So we're going to add a couple of things to it. Next thing that we're going to begin to start talking about is how we get different air pressures, okay? We know that we have different amounts of humidity in the air. Okay, we saw that between yesterday and today, right? We know that there's going to be heat transfer going on. So how is air pressure generated, and what is that all about? If I grabbed Hudson's arm and squeezed, I would be putting some what on his arm? Pressure. Pressure is nothing more than a force, right? So when we talk about air pressure, we're really talking about an air force on the planet. How much force is the air putting on the area that you're in? And we're going to be thinking about how that works. It all has to do with something called density. Everybody say density.
Density.
Now, if I said define density, raise your hand if you could do it. Seth's hand went up real quick, okay? What's density, Seth?
How thick it is.
How thick it is. Okay? Possibly, but when I think, can anybody say it differently? Okay? Dion.
Like how tightly packed the molecules are.
Ooh, you go. That is like my definition. That's Mr. Einstein right there, okay? So, what I want you to do on your paper, wherever you've got extra space and you want to do it, is I want you to write the word density. What I find is most people have an idea of what it means, but they couldn't define it. Dion, he was right on it, man. He had it going on. So we're going to use his definition because I like it. Here we go. How tightly, what did you say, Dion? How tightly what? I used another word. Packed. The what? Molecules are. Okay, so let's use an example.
Is this all we have to learn?
No. Marble, cotton ball. Which one's more dense?
The marble.
Marble, because the atoms, the molecules in the marble, are much more tightly packed, right? When you think about it, cotton ball, the matter that makes up a cotton ball has a lot of space in there, right? Okay? So if I ask you to draw an illustration, let's do 2 boxes. And again, y'all don't make fun of my art ability. You know it's not great. But let's represent something that is more dense compared to something that is less dense. Dion said something more dense is going to have its molecules more tightly packed. Okay, so let's represent that with a picture. If I use a circle to represent a molecule, tightly packed would be something like this, right? Where all the molecules are touching. There's not a lot of space in between those molecules. Does everybody agree with that? Very tightly packed. Okay? So how does that compare to something that is less dense?
All over the page.
Yeah, they're everywhere.
Okay.
There's a lot of space between it.
I like the way Rhea said that because they're not tightly packed. If they're not tightly packed, that means there's probably more space in between the molecules. Does everybody agree with that? There's more space in between the molecules. More space. So which one would represent the molecules of the marble?
The more.
The more. And the ones of the cotton ball? The less. Everybody agree with that? Okay. So why did I have you draw this silly picture about density?
So you can learn.
Because it does have something to do with our weather. Now we've just said that heat from the sun strikes the surface of the earth, and the air that touches the surface of the earth receives that heat, right? And it warms up those molecules. So, what do warm air molecules look like compared to cold air molecules? And let's think about that just a second. Okay? If I take, let's just say water, and I heat it up, and I heat it up, and I heat it up, it's eventually going to become what?
Hot.
It's going to become what?
Steam.
Water,
Vapor.
steam, which is nothing more than water vapor, right? Okay? So what happened to how packed the molecules are? What are they more packed in, a liquid or a gas? They're
Liquid.
more packed in a liquid, they're less packed in a gas, right? So as I raise the temperature, what happens to the molecules? They begin to start moving apart, don't they? Okay, so think about that in terms of warm air and cold air. Which one do you think is more tightly packed? Warm air or cold air? Talk about that with your table group just a
Cold
second.
air.
Say why.
Cold air.
Cold air. Because it's cold. Like if you have they have a lot of
Did I say hot?
Yeah.
I mean cold. I mean cold.
Okay, so which one's more tightly packed, warm air or cold air?
Cold air.
Cold air, because as you begin to lower the temperature, eventually that air is going to go from a gas to a
Solid.
liquid and then to a solid. And that's going to bring those molecules closer together, right? Okay, so let me show you what I mean. Okay, and on your note sheet, guys, now we are right there where it says, how does air pressure affect weather? Does everybody see it?
Yeah, ma'am.
Okay, how does air pressure affect weather? Warm air is less dense than cold. It's less dense than cold. When we say less dense, what do we mean by that? It's less tightly packed, to put it in Dion's words. Okay, so y'all, there's not a blank for this, but what does that mean you need to do?
Write it out somewhere on the
Thank you.
page.
Thank you, Croy. All right, so take a look at the picture that I'm showing you over here. This represents air molecules. It really represents a gas. You can tell it's a gas because the molecules are not touching one another, but they are bumping. You see the arrows representing the movement of those molecules, okay? So they're not very tightly packed. There's a lot of space in between them. This is a gas. We usually use red to represent warm, blue to represent cold, right? So compare. Even though both are gases, what happens to the packing when we start dropping the temperature? Those molecules begin to get what? Closer together. When we heat it up, they begin to start moving farther apart.
Away.
Do you see that?
Mhm.
Okay. So if warm air is less dense, then that means cold air is
More dense.
cold air is what?
More dense.
More dense than what?
Warm.
Than warm. In Dion's words, what does that mean? More tightly packed. Well, there's more tightly packed. So that helps us to better understand why warm air rises. The molecules that are becoming more tightly packed are going to sink. The ones that are spreading out more are going to move up, or they're going to rise. Probably one of the best practical examples of this is a
Air balloon.
hot air balloon, where we take this concept of warm air rising, cold air sinking, and apply it to something that we would enjoy. How many of you have ever been on a hot air balloon ride? You have? It's on my bucket list. I want to do that, but I haven't ever done it.
Well, what if it loses gas and you just fall through the air?
Like the air balloon that the balloon so you gonna float up.
Well, hopefully you've got somebody in the balloon that has some know-how of what to do. But
You carry
here's
gas
the deal.
with you.
Roy, how do they get the balloon to go up?
And the heat from the fire.
They heat the air inside the balloon, right? Now, they don't set the balloon on fire, but they do heat the air inside. And as that air is heated, the molecules spread out, and the warm air begins to rise. Okay? And so, the more they heat it, the more it's going to rise. So, then eventually you got to come back down. So, how do they cool it off?
Then you just lower
The air goes into it.
the lower the temperature.
Well, how do they do that? They turn the flame off, obviously, right? And actually, they don't leave it on all the time. It's like they heat it some and then they just let it go.
Yeah.
But there's actually some flaps up in the top, and they'll open those flaps, and it allows some of the cooler air outside to come in, and it'll cool off that air, and eventually it'll bring it down. We don't just pop the balloon, Tavia, so you don't come tumbling down to earth. That would not be
If
good.
it's a hot air balloon when you get in, it's gonna be hot.
It won't be hot in the basket on you because the warm air is going to be above you in the balloon. Now, I'm not saying you won't be able to feel maybe some heat from the burner, but you're not going to fry in there. Okay? That is on my bucket list. I want to do that one day. One of those days. All right. Well, on Monday, I'm going to show you a video clip of how this works. But for right now, we're going to stop at this point, and we're going to pick up here with air pressure on Monday. Thanks to Ryan, she brought in our last necessary bottle. Actually, I only have 14 bottles, but I figured that I could make it work with 14 instead of 15. So if you still have a bottle and you want to go for those 5 points, if you bring it to me first thing on Monday, I'll still give you those 5 points. But we do have enough bottles to do the activity on Monday. All right, so thanks, Ryan. Hey, everybody, we're going to switch gears now. I'm going to ask you to put your weather notes up. Get out page 12 of your lab. And you are going to need either a sheet of graph paper or a blank sheet of paper with your lab sheet. Okay, graph paper.